What's up everybody and welcome back to another video. Today we'll be learning about graphing quadratic equations. Now to graph quadratic equations, we want to look at the quadratic equation given to you and gather information from it in order to graph the quadratic equation. However, there are certain steps one must follow to gather the proper information. So, in today's video, I will walk you through one example, and in that example, I will walk through the steps necessary to gather the proper information. And after we finish that example, I'll give you the opportunity to try the last problem on your own. So let's begin today's lesson with example number 1. And here it is. Our quadratic equation for example number 1 is x squared plus 6x plus 9. So, let's start off with step number 1. Step number 1 to graphing a quadratic equation is to find the direction. Now, the direction of the graph basically means to figure out if the graph is increasing or decreasing, if the graph is going up or if the graph is going down. Now, remember, our format to our quadratic equation looks like ax squared plus bx plus c. And that is what our quadratic equation looks like in this example too. Now, since our quadratic equation looks like that, we know that our graph is a parabola. And by that, I mean that both sides of the graph are going in the same direction. The right side of the graph and the left side of the graph are both increasing or decreasing together. Now, to find the direction of the graph, we need to look at the a value of our quadratic equation. If the a is positive, then the graph is increasing. If the a is negative, then the graph is decreasing. So if we look at the a in our example we have here, we see that it's positive 1. And since it's positive, we know that our graph is increasing. So it's going to look something like this. Okay, now that we found the direction, let's move on to step number 2. And step number 2 is to find the vertex. The vertex is basically the starting point of the graph, the beginning point. We want to find the vertex so we know on what point to start our graph. Now our vertex is a point on the graph, so we have to find an x value and then the y value. And to find the x value of the vertex, we use the formula x equals negative b over 2a. So using that formula, let's plug in our values. So we get x equals negative 6 over 2 times 1. And then 2 times 1 is 1, and negative 6 divided by 2 is negative 3. So x equals negative 3. So now that we found our x value, in order to find our y value, all we do is plug in this value into our quadratic equation for x. So then we get y equals negative 3 squared plus 6 times negative 3 plus 9. And then after we simplify that, we just get 9 minus 18 plus 9, which is just 0. So since our y value is 0 and our x value is negative 3, we know our vertex of this graph is at negative 3, 0. So let's put this point on the graph. Right here at negative 3, 0. Okay, now let's move on to the third step, which is to find the x-intercept. The x-intercepts are points of the graph that are on the x-axis, that intersect the x-axis. Now, there won't always be x-intercepts for a graph, but you have to be able to know if there's going to be x-intercepts or not, just by judging how the graph is going to look like. Now, our x-intercepts are on the x-axis, so you should realize that there is no y value. The y value will always be 0. So that means our x-intercepts are going to look like something with a number for our x value and always 0 for our y value. And to find the x values for our x-intercepts, all we have to do is solve for x with our quadratic equation. So we set our quadratic equation equals 0, and then we solve for x. And you guys have learned how to do this, so you know that in this case you should use either factoring or the quadratic formula. Now, factoring would be the preferred choice to solve for x because it's easier and faster, but sometimes you're presented with quadratic equations that aren't factorable, and in that case you have to use a quadratic formula. Well, if we look at our example, x squared plus 6x plus 9, we see that it is factorable. So we can factor this into x plus 3 times x plus 3. So, and we can even make that into x plus 3 squared. And there's no other term. The only term here is x plus 3 squared. So there's only one x value. And that x value is x equals negative 3. So since our y value will always be 0, our x-intercept for this problem is negative 3 comma 0. But if you notice, if you look at this, you'll notice that our vertex is also negative 3 comma 0, which means our x-intercept is also our vertex. Now, it's not always like this, but in this case, our vertex is our x-intercept. So now that we found the direction, our vertex, and our x-intercept, let's move on to the fourth step, which is to find the y-intercept. And the y-intercept is just the point of a graph that's on the y-axis, which means that the x value will always be 0, but the y value will be a number. And to find the value of the y value for your y-intercept, all you have to do is plug in 0 for your x's in your quadratic equation. So if we do that, we get 0 squared plus 6 times 0 plus 9, which just equals 9. So that means our y-intercept for this problem is just 0, comma 9. But if you notice closely at this problem, you'll realize that won't the y-intercept, or the y value for the y-intercept, always be c? Because if you plug in 0 for x, these two terms are always going to cancel out. Well, yeah, then you'd be right. There's no point of plugging in 0 when you can realize that your c term in this format for a quadratic equation will always be your y value for your y-intercept. So anyway, for this problem, we know it's 0, comma 9, so let's plug in or put that point on the graph. We don't have a spot for 9 right here, but we can assume it would be somewhere around here. So there we go. Now we move on to our fifth and final step, which is to find some points on the graph. And all that means is we just need to find some more points to put on the graph so we can actually sketch our graph out and finish it. Now, something important to know before you find some points on the graph is that our parabola is symmetrical. Our graph is symmetrical. The right side to the vertex is the same thing as the graph to the left side of the vertex, but mirror. So what that means is if we find, for example, points at x equals negative 4 and x equals negative 5, the y value for these would be the same as the y values for x equals negative 2 and x equals negative 1. That might be a little confusing to understand right now, but let me go over it and then it will be much clearer. So let's find the points at x equals negative 2 and x equals negative 1. So if we want to do that, we just plug in negative 2 and negative 1 into our x's in our quadratic equation. So let's start with negative 2. So we substitute in negative 2 for x. Negative 2 squared plus 6 times negative 2 plus 9 is just 4 minus 12 plus 9, which is just negative 8 plus 9, which is 1. So that means our point at x equals negative 2 would be negative 2 comma 1. Now let's plug in negative 1. So we get negative 1 squared plus 6 times negative 1 plus 9. And if we simplify, we get 1 minus 6 plus 9, which is just negative 5 plus 9, which is positive 4. So our point at x equals negative 1 would just be negative 1 comma 4. So let's put these 2 points on the graph first. So we have 1 at x at negative 2 comma 1, and we have another at negative 1 comma 4. Now remember what I was saying earlier about the symmetry. Since we have a point at x equals negative 2 and 1, and since our parabola is completely symmetrical, we would also have a point at negative 4 comma 1. our y value for -4 and at -2 are the exact same. They're both 1. And if it's like that, then we'd also have a point at -5, 4. Our point at x equals our y value at x equals -5 and x equals -1 are the exact same, both being 4. And using this knowledge, we can also figure out that there's a point at at -6, 9. Because at x equals -6 and at x equals 0, the y value is 9. It is this way because both sides of the graph are meant to be symmetrical. So now that we have a bunch of points on our graph, let's just sketch our graph out. So like this on the left side, and something like this on the right. Okay, so there it is. That is our graph for the quadratic equation of x squared plus 6x plus 9. And we went over the 5 steps necessary to graph a quadratic equation. So now feel free to try the next quadratic equation example on your own and pause the video if you'd like to do that. So here it is. The quadratic equation for our next problem is -x squared plus 2x minus 5. So pause the video if you want to try it out on your own. Okay. Let me show you guys what it looks like. So this is our graph for the quadratic equation of -x squared plus 2x minus 5. Now, to make it so that the graph fits on the graph that we have here, I made it in scales of 2 instead of 1. But it doesn't matter as long as you have the right points and know the direction. So let's go through it step by step. First of all, the direction is decreasing or going down because the a value is negative. So we know that our graph goes in this direction. Now step number 2, to find the vertex. Well, if we use the vertex formula, x equals -b over 2a, we can figure out that x equals 1. And then after doing that, we can plug it into our quadratic equation to get y equals -4. And then we can find that our vertex is at 1, -4. Okay, step number 3. So remember how I told you in the first example that you should know if there will be an x-intercept on the graph. Well, this was a trick question, and you should have realized that there are no x-intercepts on this graph. If you notice that the direction of our graph is decreasing, as in both sides will go down, that's something important to know. Also, you have to look that our vertex is 1, -4. So if our graph starts below the x-axis and keeps going down, it will never intersect or never reach the x-axis. So that's why for this problem, there are no x-intercepts. Now for step number 4, we want to find the y-intercept. So all we have to do, like I said before, take the easy way out. Look at your c value, which is just -5, and that's why your y-intercept is just 0, -5. And your last step is just to find the points, some other points on the graph, by substituting in 2, 3, -1, and 0. And then you should have gotten these points on your graph. After doing all that, all you have to do is sketch it, and there you have your graph for -x squared plus 2x minus 5. And just before today's lesson is over, I wanted to go over the 5 steps again, which are just find the direction, find the vertex, find the x-intercepts, find the y-intercept, and then find points on the graph. If you learned something from this video or enjoyed watching it, please consider dropping a sub, and also check out our playlist on Math 2. Thank you for watching.